Hi everyone. Let's take a look at chapter 3.2, the sine and cosine ratio. Last class we talked about tangent ratio, where tan theta, where angle is in theta, equals to the length of opposite side over the length of adjacent side. We'll go over two more ratio of trigonometry. Sine ratio is another ratio we'll use in a trig unit, and it's denoted as sine A, or in short we say sin A, but we read it sine A. And it means the ratio is length of side opposite to angle A, so the opposite side over the length of hypotenuse, H. As in, if this was the angle A, then the opposite side over here, and the hypotenuse here, adjacent side here. And we'll see that opposite side is this one. The length of hypotenuse, this, is right here. In short, we say sine of A is O over H. For cosine ratio, we denote it as cos A, angle A. And the ratio is adjacent over hypotenuse. So this time I'm going to use blue one. So adjacent side here. So length of side adjacent to angle A over the length of hypotenuse. We denote it as A over H. Let's take a look at example 1. Define the sine and cosine ratio of the given right triangle. We are given two notations for angles. One's theta, and the other is alpha. Let's take a look at the angle theta ratio first. So we're looking for sine theta and cos theta. Let's first label the names of the sides relative to angle theta. So the side that's opposite to angle theta is called opposite side, and adjacent side if it's touching the angle, and the longest side of the right triangle is hypotenuse. All right, so let's rewrite our ratio. We know sine theta equals opposite over hypotenuse. So opposite side is 4, and the length of the hypotenuse is 5. For cos theta, we know the ratio is adjacent over hypotenuse. So adjacent is 3, and hypotenuse is 5. So that's it for angle theta. Let's take a look at angle alpha. So if this is angle alpha, the side that's across from angle is the opposite side, and hypotenuse stays the same because hypotenuse has to be the longest side of a right triangle, and the missing side will be adjacent one. All right, so same ratio, opposite over hypotenuse. Opposite this time is 3, and hypotenuse is 5. For cos alpha, the ratio is adjacent over hypotenuse, and adjacent relative to angle alpha is 4. Hypotenuse is 5. Understand that the names of the sides are relative to the angles. Moving on to example 2. Calculate the missing length using sine and cosine ratio. We're looking for missing length, which is h here, which is hypotenuse. There's also a typo here, so please correct it if you have the old copy. So this one, instead of 12, it's 15.59. All right. let's take a look at the angle 30. So I'll use blue for angle 30 ratios and red for 60. All right, so we will first name the side relative to the angle 30. So the side that's across or opposite of angle 30 is called opposite. And the bottom side over here would be adjacent, and then hypotenuse would be the longest side of a right triangle. Let's start with sine 30 degrees. We know that the ratio of sine will be opposite over hypotenuse, and we will sub it in. So opposite is 9, and hypotenuse is the one we're looking for, h. In fact, I'll use a little h here to follow the diagram. So I'm just going to remove this one and then post it right here. And when you're solving for h, we will have to first isolate h to have it on the top. Because this is on the denominator now, we can't just state it this way. First, you multiply h to the entire equation, and you should have h times sine of 30 degrees equal to 9. And then you will divide both sides by sine of 30 degrees to isolate h. So this cancels out. H equals 9 over sine of 30. Using the calculator app I have on my iPad, I will try to calculate it. 9 divided by sine of 30 degrees equals to 18. So h equals to 18. Now moving on to cos of 30 degrees. Cos ratio is adjacent over hypotenuse. So adjacent side is actually 15.59 over hypotenuse, which is little h we're looking for. So I'll remove this and I'll replace it right here. And we'll try to isolate h again, and then we'll confirm it this way. So we're gonna multiply both sides by h, and you have h times cos of 30 degrees equals to 15.59. Then you divide both sides by cos 30. You're left with h on the left hand side and 15.59 over cos of 30. Now on your calculator, please input 15.59 divided by cos of 30 degrees, enter. So you will get approximately 18. So 18.001, so I'll just say 18. So h is approximately 18. And that little dot on top of the equal sign means approximately. Now in red, I'll take a look at angle 60 here. So the side across from the 60 degrees angle is called the opposite side, and the longest side is still called hypotenuse, and adjacent side is the missing one. Sine ratio is opposite over hypotenuse, so opposite is 15.59, and h is what we're looking for. In order for us to solve for h, to confirm and verify, we'll have to multiply both sides by h. We will get h times sine of 60 equals 15.59. And we'll divide both sides by sine 60. And we're left with h on the left-hand side and 15.59 over sine of 60 on the right-hand side. And again, we'll input into calculator 15.59 divided by sine of 60 degrees. When you enter it, you'll get 18.0018. So that's approximately 18. So h is approximately 18 here. And lastly, cos of 60 degrees. The ratio of cos is adjacent over hypotenuse, so adjacent side would be 9. And h is what we're looking for. Again, multiply both sides by h. You get h cos 60 equals 9. And then divided by cos of 60 on both sides. So h equals 9 over cos of 60. So 9 divided by cos of 60 equals 18. So h equals 18 exactly. All right, so we have confirmed that h must be equal to 18. Moving on to example 3. Evaluate trigonometric ratios. Part A. Evaluate each ratio to 4 decimal places. So sine of 25 degrees, we'll try inputting into the calculator. Sine of 25 degrees, and you enter. And you can see that it's 0.4226. 0.4226. And for cos of 89 degrees would be cos of 89 equals 0.0175 when you round it up. 0.0175. All right, that's pretty easy. Inputting into the calculator is really easy, but make sure to double check if your calculator is in degree mode. So your calculator should have something like this on the top right corner or top left corner. So part B, determine each angle measure to nearest degree. So nearest degree means nearest whole number, okay? Or like integer number. All right, so in order for us to solve the angle theta, we do need to learn a little bit about inverse trigonometric functions. The notation we'll use is arcsine or sine inverse. Arcsine here. They're the same thing. On your calculator, you might have this button or this button depending on the brand. So make sure, just understand that they're both same thing, okay? So we must perform the opposite operation to find the missing angle. Okay, this is why we need this inverse trig functions. So for example, if we have sine theta equals 0.4771, we have to inverse both sides. So sine of inverse of sine theta. On the left-hand side, this will give us angle theta on its own. So you can't just divide, you can't just divide sine to get theta. This is not a fraction. So understand that in order for you to get rid of the trig function, you need to undo it by using an inverse trig function. Okay. So on the right-hand side, we'll have to inverse sine as well. So whatever you do on the left-hand side, you do on the right-hand side. Left-hand side, we have theta left, and then we'll have to input into the calculator to find out what that function gives us. All right, so let's take a look. So this time, do you see this button? Sine inverse or arcsine, what we call, and then you do 0.4771 and you enter it. and you will get 18.496 and so on. So that rounds up to the nearest degree, as in 28 degrees. So I'll first write down up to 4 decimal places and we'll round it up. So theta equals 28 degrees. Okay, this is our final answer. Same for cos theta. So when you're looking for the angle theta, we need to use inverse trig function, and in this case, we'll have to use inverse cos, or you call it arc cos. So this equals cos inverse of 0.7225, just like that. All right, so on the left-hand side, we'll be left with angle theta, and let's calculate the right-hand side using calculator. So arc cos of 0.7225 equals 43.7387, and then I'll write that down first, 43.7387, and this rounds up to 44 degrees, like that. All right, so inverse trig functions must be used when you're solving for angle theta. So we can undo that first trig function. We need inverse trig functions. And please memorize these 3 trig ratios. Sine is opposite over hypotenuse. Cos is adjacent over hypotenuse. And tan is opposite over adjacent. So katoa. So that's it for today. I'll see you guys in the next video.